Thank you. Hopefully you can all see this. So thank you for accepting my talk proposal. And so what's the goal of this talk, if you haven't read the abstract? It's just there are many companies, many tools that claim to be able to detect whether text was produced by AI or not. And some universities, some institutions are putting this as part of their policies or even are basing their policies on this. I think this is a bad idea. So I'm arguing against that. So the goal of the talk is to sort of give you an overview of why I believe that, of course, but mainly to explain what's going on and why I think we should move in a different direction. So just to start 4 sections really quick, a bit of an overview of large language models, of which ChatGPT, BARD, and others are examples. Effectiveness of detectors, whether we should even detect, and then a bit of positive ending on what we could do instead. So a large language model is simply a tool that takes a string of words, your input, so what you write in the prompt, and outputs another word. So for instance, if you were to put twinkle, twinkle, little, then the model might output star. And then what it does is that it deletes the first token if the prompt is too big. So it cannot consider infinite text, which is why it cannot write a book. So in a way, this is all they do. And yet the training and the way the word is picked allows them to be incredibly effective at mimicking human speech. So again, the probability is generated by training lots of human generated text. And the tokens are taken to be words. So it generates word after word after word. Now, the important thing to note is that there is randomness in the generation process. So if you put in an input, it will not always get the same outputs. And this is because of how the word is picked, where there is a random step at the end of it. So given a language model, though, which picks a token, ChatGPT is a simple iteration of that, where it basically only does that. But you can put it in a bigger context, just like one of your neurons is probably a very simple thing, but when you put it in touch with all the others, it becomes a brain. Then you can take a model and, well, prompt engineering means use your prompt to unlock particular abilities. For instance, pretend you are a scientist or talk to me like a parrot, or we've all seen many of those. Fine-tuning, where you retrain the model sort of to steer it towards a particular output. Iteration, where you make the model to look at its own output and make it better. You know what reward models are. Filters, which are why models don't swear at you, even though in some cases a human would. And then you can put models on top of other models and make them interact. And finally, there's plugins with which a model can talk to an external service, query it, and get back an answer. An example, Wolfram Alpha, the popular maths engine system, can now talk to GPT. So if you ask GPT to do an integral, then GPT can query Wolfram Alpha, get back the answer, and interpret it in context. So what can it do? Well, there's a list of all the stuff it can do, and we've all seen it can generate text, write computer programs, and so on. But effectively, it can answer queries and perform tasks as instructed. Now, of course, this doesn't mean it's perfect or it can do those things well. But what it can do in general is it can mimic a human conversation and inform this conversation with several external information through plugins or the training data. So, there's not just one. GPT is the most famous one, but there's Claude by Anthropic, Meta AI has got their own one, and there's BARD from Google. And these are generally different models. So they are different creatures in some sense. And also there is derivative stuff. So GPT now has plugins. There is an API with which you can make GPT talk to your service. And Meta has got the weights linked. And there's now Alpaca from Stanford, which is a very interesting model for research purposes because it's really small compared to the others, but it performs really well. But the point is there are lots. There's not just ChatGPT and that's it. There's many models. There will be more in the future. And on top of that, there are derivative ones, which look really different. If you talk to Bing, it seems a completely different one from GPT, and yet it's based on the same creature in some sense. So first important point I want to make is that large language models today are not large language models of tomorrow. So today they're clunky. We are in the bit of the initial phase. So to talk to a language model, you have to go to a separate interface, maybe ChatGPT, maybe an app, maybe a browser, text-based input. So you have to copy and paste your inputs and your outputs. They can't do a lot of stuff. They're limited in what they can do through various, for example, token limits or just slow or input size. The more advanced ones are behind waitlists or paywalls or both. So in some cases, you need to be a developer to access a particular version of a model. They are in browser, so they're not on your computer. They're just query to an online service, and they're largely generic. If all of you that use GPT, just use GPT. But imagine if you had a model for everything you want to do. So a model for emails, a model for essays, a model for research, and they would be fine-tuned through that. So indeed, tomorrow instead, what we're going to have is integrated ones. If you haven't seen the Microsoft Copilot presentation video, please do, because it will informs what this will be like in a few months. By the way, all my slides are interactive, so if you get them later, you can click on almost every picture and get the source. There will be multimodal, which means it's not just text. So GPT-4 can already look at pictures and identify what is going on in pictures. And Be My Eyes as a preview. Be My Eyes is an app that for blind people or visually impaired people that you put something in the camera and a volunteer describes what it is. But now GPT can do that. And then there will be higher availability, specialized models that will be everywhere, not just in a browser. And of course, we will be able to process much more data than they currently do, just because the subject works, right? So limits are mostly temporary. So do not focus on the current implementation, like block GPT on your browser or something, but think ahead in that this will be in your email, in your Microsoft Word, in your computer, even in your phone, probably in your fridge. So think about something like that. So ultimately, what it can do right now is not very useful or interesting to us because it takes a lot of time to develop a policy, right? Think about e-assessment and all the work that's been done and is currently being done to figure it out and get it right. So if we keep playing catch up with generative AI, we may just lose because we don't have time to understand exactly what's going on, and time goes on and we have to change everything again. So my suggestion is work as if generative AI was already better at things which is now currently not great at, and aim for one radical big change. And the question I want to ask in this talk is, should detection play a role in this change? So should our policies involve detecting generative AI usage in student essays or whatever you think might be detected? Well, so bit of an overview. Currently, there are basically 4 types of detection, which I characterize as human insight, machine learning, watermarks, and surveillance, which some people call fingerprinting because it's more user-friendly. So human insight is what you think it is. Sometimes you can just tell. So here's our examples from Reddit. Actually, no, 2 are from Reddit. This is from a reference letter that was written for me, and at the end, there were the word regenerative response, which if the person who wrote this is reading this, I fully endorse that. I use GPT too, and I think it's a good thing. But nevertheless, if these were forbidden for some reason, I would have easily been able to tell that this person used GPT. And so sometimes you can just tell. So of course, sometimes your insight can tell you that GPT was used. These are very obvious examples, but there are other subtleties that you currently might be able to pick up. But I want to warn you, beware of what I call the Canva effect, and it's called the lazy user models in TA research. So okay, this slide is from January, so I know you probably have forgotten about the Christmas cards you got. But you probably got a lot of these this year because everyone started using Canva, and these were the top 10 templates for Christmas cards. So Canva is an incredibly versatile tool that can basically produce billions of different graphics. But the way most people used it is just clicked on it, looked up Christmas card, clicked on one of the nice first results, and just go with it. Same reason why companies pay a lot of money to be on page 1 of Amazon. Nobody looks at page 2. So there are many simple inputs. So basic users of Canva are very detectable. Most people that use Canva indeed will have used one of these, so I know they use Canva. Not that there's anything wrong with it, but if I want to detect that, this is the way. But advanced users are not detectable. So if you use GPT, for instance, to say to write a cover letter as Bob Smith, yada yada, then that's probably going to produce a very standard one, and you can probably at least see or detect that GPT wrote that. But if I give it a slightly more complicated prompt, then you're probably just not going to be able to tell, because it will look different from your standard ChatGPT as produced letter, and your human insight is not going to work. By the way, there is research on this where people were asked to do the sort of Turing test to tell whether this was AI or not, and people failed miserably at that as soon as the prompts go harder. So human insight works for low-hanging fruits, but don't think it can pick up everything just because it can pick up something. So the biggest one is, of course, machine learning detectors, where AI is trained to identify AI. So there are a few here. There's tons of websites that promise they can do that, but there are also big companies with a good reputation. So OpenAI put out their own AI text classifier, and Turnitin put out their own AI writing detection tool. So it's basically software that takes text and identifies sentences. Now, the way this works is basically, initially they try to identify if the weights in the words match those on the model. But then later, this is put in a machine learning context where this was the basic idea. And then basically an AI is trying to identify AI-produced content, and this is iterated. They claim various degrees of accuracy, but the point is the data sets. What a large language model can write is probably way too big for any data set to be comprehensive, just because it can write in any style, change different words, you can change parameters. So claiming accuracy on a data set is not very indicative of overall accuracy or overall specificity or overall sensitivity. But so a few problems with these are, the first is that these are trained to identify fully large language model generated content. So most things are co-created. If you use GPT, I do, normally there's like a conversation. I tell you what I want to do, or I put a draft and then I change the draft and then I put it back in. And indeed, these classifiers are not trained to detect documents co-written with AI, which will be soon the main use case, because again, it will be in Word, it will be in Outlook, and so on. They are very vulnerable to paraphrasing. And also there is evidence that this is not a temporary hiccup of machine learning detectors, but there's a paper out which says, yeah, you can't really ever detect with sufficient precision. So I tried to give you an example, but basically I had GPT-4 and I was trying to come up with some prompts, which was not too obvious. So I asked it to write 500 words on bananas, and yeah, the detector didn't work. This is full, so this is a one sentence prompt, and GPT-4 wrote the essay, and the detector didn't work. And indeed, I was actually unable to get these detectors to detect GPT-4. So I had to go back to GPT-3, which is the free one. And so I asked it to write 500 words on Stonehenge. Actually, interestingly, AI text classifier still failed, but Zero GPT somehow worked. And however, very simple thing that you can find on every student website, GPT-1 is just replaces random words with synonyms. So it's a one-click thing, it's free. And now you see what it did to Zero GPT. So basically, even if you have a detector that claim somewhat decent accuracy, as soon as you put 1% of human code writing, which might be a random text scrambler, these things seem to fail. And if you think about how they're built, this is pretty much inevitable, which is the point the other paper was arguing. So there are really big problems with this on effectiveness, accuracy, and how easy it is to circumvent whatever they are good at detecting. But there's more problems. So these are trained on human-generated text, right? So ChatGPT is trained on a lot of text written by humans. So the words it picks are sort of guaranteed to be similar to the words that most humans in some sense would pick. And no native English speakers have a lower degree of variation in their writing, because obviously, in a way, they know less words, or they know less grammar, or they know less, syntactic structure, because they're just learning English. And so, indeed, there is evidence that they show bias against non-native English speakers, or against people who with dyslexia, or anything that uses AI to structure their sentences. AI-like methods to structure their sentences, in that they follow certain rules which are ingrained in their minds, either by the English teacher or by some other methods. And so there's a bias problem. And further, as models get better, they can write more text. And as they can write more text, the detector has a harder job detecting it. And again, most outputs will soon be co-written. And you're actually currently able, it's not easy, but you can train an AI on your text. Just you can ask it to write like Shakespeare, you can ask it to write like you, after you've given it enough stuff. And then, well, you can actually make it write like you would. So there's a problem here about effectiveness, that these things aren't really going to work. Watermarking. Watermarking is something that the company will do. So it is possible that, for example, OpenAI makes the model pick words in a certain way. This is an example. Imagine you divide all the tokens in two sets, blue and red, and you put a rule that blue and red have to alternate. So this way you would be able to detect GPT-generated text with high accuracy, because it would look like this, which is very unlikely if a human was writing it, that it would pick a blue and a red word alternatively. But of course, the issue is that if you rely on watermarking, then any other non-watermark model can either paraphrase or just not work. And of course, there is a strong business case for non-watermark models. And given how Alpaca from Stanford has freely available weights, the cat is already out of the bag. So that one is not watermarked, and it will be there and it will stay there. So watermarking is not likely to be a solution. And finally, it's what I call surveillance. So the idea is the student works in a controlled environment, and this is used to validate authenticity. So the vanilla version of this is a keep track of drafts. I asked my project students this year to send me more drafts than usual. So I see their progress, and I know they're sort of doing the work. Controlled VLE is a bit of the already pretty red area. And then Turnitin, which hasn't been excellent in all this, actually says, I want to fingerprint the student's writing, and then I flag everything else that differs significantly, which I've characterized as 1984 level. Again, there are issues with co-creation, because it's unclear how this stuff would perform on co-created content, but also this is mass surveillance. So let's call it how it is. The usual problems with mass surveillance protocols apply, singling out certain people, or accessibility issues, anxiety for people who are wrongly accused of having done something. And so these are the 4 ways of detecting and the problems I see with that. But I want to make a wider point that we actually do not want to detect in that. What detectors do is not what we need to do, what we want to do. And I want to draw a parallel, because Turnitin, for example, has been playing a lot on this parallel between plagiarism and AI detection, but they are different things. So plagiarism detection, first of all, is falsifiable. So it tells you what was plagiarized, and you can actually go and have a look. But then it tells you exactly what you want to know. It's actually exactly that this paragraph was not original. But AI output detection only tells you how much of the final text is likely to have gone through an AI. And this does not tell you whether the student wrote it, because it might just be a case of a student using it to paraphrase their own work to make it look better, or for feedback, or how do I say this better? I don't like how it sounds. So these are misaligned tools, in that we want them to use to ascertain how much of the work is the student's work, but they don't do that. They only tell you how much of the final output went through possibly went through a language model without the ability to verify that independently. So again, if you consider 2 students, you got Alice, who writes a draft essay and has asked GPT to help her with revision, and then evaluate some suggestion and implement some of those. This will likely get picked up by a detector. But then Bob generates an essay with GPT, changes a few words, either by doing some work or through stuff like GPT-1, the paraphraser, or and then the detector is unlikely to perform. So we actually don't care a lot about how much of the text was written by AI. We care about authentic assessment, which is how much of this was the student's own work. So this is what I mean by misaligned tools. And again, this is not falsifiable. And I argue that some people say, okay, but I apply a balance of probability approach so that I look at what the detector tells me, and then I try to use other data to come to a conclusion. But if you use a detector, and we've seen they're not very accurate, and we see they can have false positives, I argue that they introduce bias. So Turnitin made the decision recently of automatically turning on the AI indicator so that in the plagiarism report, you would see that. Now, UK universities sort of lobbied against this and managed to add the option to turn it off. But initially, this was not in their plans. And some colleges which turned it on, so a lot of students wrongly accused of malpractice, and that's expected. But what we aren't able to monitor, at least now, is the bias introduced into the process. If I'm marking an essay and there's a little box that says this is 75% AI generated, I'm going to look at it differently. You're going to look at it differently. This is just unconscious, conscious bias. And since that data is basically a coin toss, it means nothing for the reasons we've seen, then we don't want to see that. So, okay for the balance of probability, but since this doesn't actually tell us what we want to know, then it just ends up hurting us, because maybe an essay is AI generated, but the detector says 0, and we're like, oh, okay, then maybe I'm wrong. This is the student's own work, even though I think it's not. Vice versa, maybe an essay is marked as AI generated when it's not, and I'm going to look at it much more critically, and I'm going to be like, oh, I can see that this student didn't have this opinion. So there is an issue with detectors being there in the first place, regardless of how much you think you can be critical. And malpractice is a serious matter. So in colleges where the Turnitin policy worked, or where professors just went using random detectors on the internet, a lot of students, if you go on Reddit, which I like because it's anonymous, but also it's based on content, not on profile, so people are not really inclined to exaggerate, at least not as much as they would on other social media. You see a lot of students complaining that they're being accused of using AI for no reason, and they didn't. And basically what professors are doing is they're applying current policies against plagiarism to AI, but anti-plagiarism detectors are accurate and can be checked independently, and AI detectors do neither. So we should not apply the same logic, because these are not the same things, regardless of how much companies try to tell us they are. There's a few more issues that I don't have the time to delve into, but again, accessibility tools will soon make extensive use of generative AI. So people who use this would likely get picked up by detectors, and this is inevitable. So policies would discriminate against students who rely on those, or would force students to disclose any vulnerability in order to be exempted from that. And then privacy issues, of course. If you have a ban detection policy, students would paste their work, regardless of whether they use AI or not, into these dubious websites to check it's not flagged, just in case. Because if they get wrongly flagged, then they're in trouble. So they're just going to paste it. And of course, the website that can then use their data for whatever the website wants to do. So there are issues here with that. If you have AI, for instance, in Microsoft Word or OpenAI, you can at least have a privacy policy and accountability for the company. But if it's a dubious website you just Google and you don't even know anything about it, students paste their work in there, but that's a bit harder to mitigate. So bottom line, pushback against detection. They are unreliable, they introduce bias, they're non-falsifiable, they have mismatched goals where you want to measure something and the detector measures something else. And they tackle the wrong problem. And also, since most content is going to be co-written or tailored on you, not just by generic model that you can now maybe detect, these policies would soon be obsolete anyway. And of course, there is a strong business incentive for plagiarism checker companies and other companies to just try to sell you detection, claiming it's super effective. And the reason is, who is going to plagiarize when you can generate? So plagiarism, I think, is going to disappear very soon as students learn that they can do something else instead. So do not fall for it. That's all I'm saying. They're going to aggressively, they have already aggressively pushed this detection on the markets, or some companies have given up and their shares dropped by 50%. But just be aware, that this is the business environment. They have a strong incentive to oversell what they have. So, few more points. You can't just ignore. So some people might say, okay, I'll have closed book examinations. Let's just ignore that large language models exist. But you really can't do that. I mean, you can, but it's not a great idea because first of all, they're going to be asked about them in the workplace. And this is going to be integrated in their software. So students will use them and will be used to using them. But also we scale marks. So if you have a policy that says you should not use AI in my class, if you use it, I'm going to punish you, which I've seen many of, then first of all, you cannot detect it. So this is an empty threat. But what's the effect of an empty threat? You have the risk-averse student that doesn't know better, and she believes this. Well, in this case, it's Alice, so she believes this. And she chooses to just not use it. So not only her grades drop because everyone else's go up and we scale, but also maybe she puts her work into detectors with the previous issues. So she ends up being more anxious and her grades go down. Other students who are risk takers know exactly how to fool detectors, so they use AI in a good way and their grades go up, and this is great. But also other students use AI in a bad way and their grades also go up because you can't tell them apart if your assessment is based just on a ban policy and you don't do something else. So if you ban it, you just damage compliant students, which is probably the opposite of what any policy wants to do, right? So you cannot just ban it, you cannot detect it, you cannot even formally forbid it without actually being able to enforce the ban, because some students are going to believe you, and then they're going to end up damaged because of that, because their performance is going to be comparatively lower, because AI is good, it helps people do stuff, makes them faster, quicker, gives them feedback, and so on. So my argument is that you need to be instead explicitly tell them how to use it, and well, be critical, how to use them effectively, and the ultimate goal would be to encourage and allow language models usage, and then assessing students in an authentic way, which is immune to that. So what's something to think about? Well, calculators, right? I'm in maths, so obviously that's an example. It's not a great example because they're very disruptive, but it's a good idea. So calculators in primary schools, everyone was talking about it back in the day. Oh, what are we going to do? Students are just going to use this in their homework. But what happened with that is that students now understand calculators. Some types of exercise just disappeared. So for instance, compute a logarithm. Not many students are able to do that, but it used to be quite a question to be assessed on with all the tables and whatnot. We do have some non-calc papers. There are some things that we want to assess students without calculators, but then we create control conditions to do that. And otherwise, we assume that students can use them. When we tell a student, you shouldn't use the calculator in your homework, then we don't enforce that by going into their home or having them use a VLE to do their additions. We just say, in the assessment, you won't have it. So it's a good idea not to use it. And they understand that, and this works. Of course, things are not this easy with language models, but I think it's a good mindset to be in, that how we manage other stuff was not by mass surveillance or banning it, but just going around it and devising authentic assessment methods. So a desirable endgame, in my opinion, would be where students are explicitly educated on this. ILOs are changed a little to take into account the existence of language models. There are some assessments which have to be done without language models, and then they take place in a controlled environment, but these are only around these assessments. So it's a very small part of the course. It's not that it's forbidden throughout it and they can never use it. And then authentic assessment is itself an effective motivator. So we encourage students to learn skills because they're being assessed on these skills, and also because we tell them why it's important that they learn the skills, regardless of AI doing it, just like with calculators. And of course, this is going to take ages, right? So what do we do? Well, this is figured out. And I mean, even just changing ILOs takes like a year in some institutions. So, well, educate students on malpractice. And by educating them, I don't mean saying, we will expel you if you do this. I mean, what does malpractice mean? Why is it bad? I would say, I think we haven't done enough work on that in the universities. I think we could talk more about it. In-person invigilated exams are a safe haven. They're not the only option. So for instance, if you have a small summative assessment, then there's actually a formative one in which you use a small percentage of the final grade to motivate them, right? So it's probably fine, as long as it's not all assessed through something that's easily falsifiable. Then you might need to change something. Consider tracking drafts, but not like through fingerprinting or some weird non-validated approach, but just like asking your students to submit 3 or 4 of those, and then maybe looking back at those if you suspect that they really didn't do their work, and use your general insights, but in a very, non-aggressive way. Again, I wouldn't ban it. I wouldn't pretend to be able to detect them. I would set clear guidelines, but as guidelines in that you're not going to be expelled if you don't follow this, but you're not going to learn the way you should learn. So you should use language models this way, not that way. And a lot of students actually want to learn. So this could work in some cases as long as assessment is authentic. And of course, the human interaction assessment, for instance, presentations, oral exams, a little written task for those people who use labs, so experiments, are good. And of course, if you see an excellent essay with a very bad Q&A, then that's an anomaly. And then, of course, universities already have contract cheating policies, malpractice policies to deal with stuff like essay mills. And in that case, in those cases where you actually suspect something is really wrong and probably the student did not do any of the work, then you can use those, but with caution. And also these are tested and they've been through many, many years of iterations. So they're probably better than you just going off on your own with a detector and accusing a student of something. So if you have to accuse a student of something for reasons that do not involve detection, you should do that, because you can cheat with AI. Some students will cheat with AI, and we should not allow that, but cautiously. So that's kind of my talk. Happy to take any questions and anything. There are lots of links. So first of all, when the slides are available, you can click on almost every picture and there will be a link. And there's a few stuff I like about things you can read, and you can follow me on Twitter or whatever. Thank you very much for inviting me.